Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12th physics, moving charge and magnetism. Chapter 4, NCERT solution, part 2. Our mission is to provide free classes on YouTube for all the students of class 6 to class 12 and also for the students who are preparing for IIT, JEE, NEET, NDA and other competitive examinations. Before we begin, we request you to subscribe, like and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded. Let us begin today's class. In the last class, we have completed question number 4.9. In today's class, we'll begin with question number 4.10. Two moving coil meters M1 and M2 have following particulars. R1 is equal to 10 ohm, N1 is equal to 30. A1 is equal to 3.6 multiplied by 10 to the power minus 3 meters square. B1 is equal to 0.25 T. R2 is equal to 14 ohm, N2 is equal to 42. A2 is equal to 1.8 multiplied by 10 to the power minus 3 meters square. B2 is equal to 0.5 T. The spring constant are identical for the two meters. Determine the ratio of A. Current sensitivity, B. Voltage sensitivity of M2 and M1. Let us see the solution. So here we are given for moving coil meter M1, resistance R1 is 10 ohm, number of turns N1 is equal to 30, area of cross section A1 is equal to 3.6 into 10 to the power minus 3 meters square. Magnetic field strength B1 is equal to 0.25 T. Spring constant K1 is equal to K. For moving coil meter M2, R2 is equal to 14 ohm. Number of turns N2 is equal to 42. Area of cross section A2 is equal to 1.8 into 10 to the power minus 3 meters square. Magnetic field strength B2 is equal to 0.5 T. Spring constant K2 is equal to K. A. Current sensitivity of M1 is given by I S1 is equal to N1 B1 A1 upon K1. Current sensitivity of M2 is given as IS2 is equal to N2 B2 A2 upon K2. Ratio of IS2 upon IS1 is N2 B2 A2 upon N1 B1 A1. Putting the values, we get 42 multiplied by 0.5 multiplied by 1.8 multiplied by 10 to the power minus 3 multiplied by K upon K multiplied by 30 multiplied by 0.25 multiplied by 3.6 multiplied by 10 to the power minus 3, which is equal to 1.4. Hence, the ratio of the current sensitivity of M2 to M1 is 1.4. Now part B. Voltage sensitivity of M2 is given by Vs2 is equal to N2B2 A2 by K2 R2. Voltage sensitivity of M1 is given by Vs1 is equal to N1B1 A1 upon K1 R1. Therefore, ratio is equal to Is2 upon Is1 Just a minute. So there was a correction. We have done Vs2. The ratio of Vs2 upon Vs1 is equal to N2B2A2 K1R1 upon N1B1A1 K2R2. Putting the values, we get 42 multiplied by zero point 0.5 multiplied by 1.8 into 10 to the power minus 3 multiplied by 10 multiplied by k upon k multiplied by 14 multiplied by 30 multiplied by 0.25 multiplied by 3.6 multiplied by 10 to the power minus 3 is equal to 1. Hence the ratio of the voltage sensitivity of M2 to M1 is 1. So the next question is 4.11. In a chamber, a uniform magnetic field of 6.5 G, 1 G is equal to 10 to the power minus 4 T is maintained. An electron is shot into the field in, with a speed of 4.8 into 10 to the power 6 meter per second. Normal to the field. Explain why the path of the electron is circle. Determine the radius of the circular orbit. E is equal to 1.6 into 10 to the power minus 19 coulomb. Me, that is the mass of the electron, is given as 9 into 1 into 10 to the power minus 31 kg. Let us see the solution. So magnetic field strength B is equal to 6.5 G is equal to 6.5 into 10 to the power minus 4 T. Speed of the electron is equal to B is equal to 4.8 multiplied by 10 to the power 6 meter per second. Charge on the electron E is equal to 1.6 multiplied by 10 to the power minus 19 coulomb. Mass of the electron Me is equal to 9.1 into 10 to the minus 31 kg. Angle between the short electron and the magnetic field theta is equal to 90 degree. Magnetic force exerted on the electron in the magnetic field is given as F is equal to EV B sine theta. So the force provides centripetal force to the moving electron. Hence the electron starts moving in the circular path of radius r. Hence the centripetal force exerted on the electron Fe is equal to mv square upon r. In equilibrium, the centripetal force exerted on the electron is equal to the magnetic force, that is Fe is equal to F, which implies that mv square upon r, which is equal to the centripetal force, is equal to EVB sine theta, which is equal to magnetic force, which implies that r is equal to mv upon EB sine theta. Putting the values, we get r is equal to 9.1 into 10 to the power minus 31 into 4.8 into 10 to the power 6 upon 6.5 multiplied by 10 to the power minus 4 multiplied by 1.6 multiplied by 10 to the power minus 19 multiplied by sine 90, which upon calculating we get 4.2 multiplied by 10 to the power minus 2 meter, that is 4.2 centimeter. Hence radius of the circular orbit of the electron is 4.2 centimeter. Let us see the next question. So the next question is 4.12. In exercise 4.11, obtain the frequency of the revolution of the electron in the circular orbit. Does the answer depends on the speed of the electron? So in question number 4.12, all the values are same as that of 4.11. For those values, we have to obtain the frequency of revolution, and we have to find out if the speed if that frequency depends on the speed of the electron or not. So let us see the solution. So magnetic field strength is given as 6.5 multiplied by 10 to the power minus 4t. Charge on the electron is 1.6 into 10 to the power minus 19 coulomb. Mass of the electron Me is equal to 9.1 into 10 to the power minus 31 kg. Velocity of the electron V is equal to 4.8 multiplied by 10 to the power 6 meter per second. Radius of the orbit R is equal to 4.2 is equal to 0.042 meter. Frequency of revolution of the electron nu is equal to nu. Angular frequency of the electron omega is equal to 2 pi nu. Velocity of the electron v is equal to omega r. In the circular orbit, magnetic force on the electron is balanced by the centripetal force. So we can write mv square upon r is equal to evb. Eb is equal to mv by r, which implies that ev is equal to mv by r, which is equal to, putting the value of v as r omega, we get m r omega by r. Again, instead of omega, we write 2 pi nu, then the equation becomes m r 2 pi nu. So instead of omega, we have put 2 pi nu here. Instead of v, we have put r omega. So now the equation is nu is equal to be 2 pi m. The expression of for the frequency is independent of the speed of the electron. On substituting the known values in this expression, we get the frequency as nu is equal to 6.5 multiplied by 10 to the power minus 4 multiplied by 1.6 into 10 to the power minus 19 upon 2 multiplied by 3.14 multiplied by 9.1 multiplied by 10 to the power minus 31 is equal to 1.82 multiplied by 10 to the power 6 hertz, that is 18 m hertz. Hence, the frequency of the electron is around 18 megahertz and is independent of the speed of the electron. Let us see the next question. Now let us see the question number 4.13a. A circular coil of 30 turns and radius 8 cm carrying a current of 6 ampere is suspended vertically in a uniform horizontal magnetic field of magnitude 1.0 Tesla T. The field lines makes an angle of 60 degree. With the normal of the coil, calculate the magnitude of the counter torque that must be applied to prevent the coil from turning. B. Would your answer change if the circular coil in A was replaced by a planar coil of same irregular shape? of same irregular shape that enclosed the same area. All the other particulars are to be unaltered. Let us see the solution. So, number of turns on the circular coil n is equal to 30. Radius of the coil pi r square is equal to pi 0.08 square is equal to 0.0201 meter square. Current flowing in the coil I is equal to 6 ampere. Magnetic field strength B is equal to IT. B is equal to 1T. Angle between the field lines and the normal of the coil surface is equal to theta is equal to 60 degree. The coil experiences a torque in magnetic field, hence it turns. The counter torque applied to prevent the coil from turning is given by the relation tau is equal to NIBA sine theta. Putting the values 30 multiplied by 6 multiplied by 1 multiplied by 0.0201 multiplied by sine 60 degree is equal to 3.133 Newton meter. Now let us see the part B. So it can be inferred from the relation tau is equal to IBA sine theta that the magnitude of the applied torque is not dependent on the shape of the coil. It depends on the area of the coil. Hence, the answer would not change if the circular coil in the above case is replaced by a planar coil of same irregular shape that enclosed the area. Let us see the next question. The next question is 4.14. Two concentric circular coils X and Y of radii 16 cm and 10 cm respectively lie on the same vertical plane containing the north to the south direction. Coil X has 20 turns and carries a current of 16 ampere. Coil Y has 25 turns and carries a current of 18 ampere. The sense of the current in X is anticlockwise and clockwise in Y. So X has anticlockwise direction and Y has clockwise direction. The current direction in X is anticlockwise and current direction is of the current direction in the coil Y is clockwise. For an observer looking at the coil facing west, give the magnitude of and direction of the net magnetic field due to the coil at their centers. Let us see the solution. So radius of the coil X is equal to R1 X. Radius of the coil X R1 is equal to 16 cm, that is 0.16 meter. Radius of the coil Y R2 is equal to 10 cm, that is 0.1 meter. Number of turns of coil X N1 is equal to 20. Number of turns of coil Y N2 is equal to 25. Current in the coil X I1 is equal to 16 ampere. Current in the coil Y I2 is equal to 18 ampere. Magnetic field due to the coil X at their center is given by relation B1 is equal to mu naught N1 I1 upon 2 R1, where mu naught is equal to permeability of free space, that is 4 pi multiplied by 10 to the power minus 7 Tm A inverse. Putting the values B1 is equal to 4 pi multiplied by 10 to the power minus 7 multiplied by 20 multiplied by 16 upon 2 multiplied by 0.16, that is equal to 4 pi 10 to the power minus 4 t towards east. Magnetic field due to coil Y at the center is given by the relation B2 is equal to mu naught N2 I2 upon 2R2, where mu naught is equal to permeability of free space, that is 4 pi 10 to the power minus 7 T M A inverse. So B1 is equal to 4 pi 10 to the power minus 7 multiplied by 25 multiplied by 18 upon 2 multiplied by zero point 0.1, that is equal to 9 pi 10 to the power minus 4 towards west. Hence, net magnetic field can be obtained as B is equal to B2 minus B1, which is equal to 9 pi multiplied by 10 to the power minus 4 T minus 4 pi multiplied by 10 to the power minus 4 T, which is equal to 5 pi multiplied by 10 to the power minus 4t, which is equal to 5 into 10 to the power 3.14 multiplied by 10 to the power minus 4t, which is equal to 1.57 multiplied by 10 to the power minus 3t towards west. Let us move to the next question. Now we'll solve problem number 4.15. A magnetic field of 100 G, 1 G is equal to 10 to the power minus 4 T is required, which is uniform in a region of linear dimension about 10 centimeter and the area of cross section about 10 to the power minus 3 meters square. The maximum current carrying capacity of a given coil is 15 ampere. The number of turns per unit length that can be wounded around the core is at most 1000 turns per meter. Suggest some appropriate design particular to the solenoids for required purpose. Assume the core is not ferromagnetic. Let us see the solution. So magnetic field strength B is equal to 100 G, that is 100 multiplied by 10 to the power minus 4 T. Number of turns per unit length N is equal to 1000 turns per meter. Current flowing in the coil I is equal to 15 ampere. Permeability of free space mu is equal to 4 pi multiplied by 10 to the power minus 7 Tm A inverse. Magnetic field is given by the relation B is equal to mu naught and L. Ni is there was a small correction. B is equal to mu naught Ni. Therefore, Ni is equal to B upon mu naught. Putting the values, we get 100 multiplied by 10 to the power minus 4 upon 4 pi multiplied by 10 to the power minus 7. Upon solving, we get 7957.74, which is equal to approximately equal to 8000 ampere per meter. If the length of the coil is taken as 50 centimeter, radius 4 centimeter, number of turns 400 and current 10 ampere, then these values are not unique for a given purpose. There is always a possibility of some adjustment with limits. Let us see the next problem. Now let us see problem number 4.16. For a circular coil of radius r and n turns, carrying current I, the magnitude of the magnetic field at a point on its axis at a distance x from its center is given by B is equal to mu naught I r square n upon 2 under bracket x square plus r square to the power 3 by 2. A. Show that the reduced this reduces to the familiar result of for field at the center of the coil. B. Consider two parallel coaxial circular coil of equal radius r and number of turns n carrying equal current in the same direction and separated by resistance r separated by a distance r. Show that the field on the axis around the midpoint between the coil is uniform over a distance that is small as compared to r and is given by B is equal to 0.72 mu naught Ni upon r approximately. Such an arrangement to produce a nearly uniform magnetic field over a small region is known as Helmholtz coils. Let us see the solution. Radius of the circle coil is equal to R. Number of turns on coil is equal to N. Current in the coil is equal to I. Magnetic field at a point on its axis at a distance x is given by the relation B is equal to mu naught I r square N upon 2 bracket x square plus r square to the power 3 by 2, where mu naught is equal to permeability of free space, that is 4 pi multiplied by 10 to the power minus 7 T m A inverse. Now A, if the magnetic field at the center of the coil is considered, then x is equal to 0. B is equal to mu naught I r square n upon 2 rq, which is equal to mu naught I n upon 2 r. This is the familiar result for magnetic field at the center of the coil. Radii of two parallel coaxial circular coil R is equal to R. Number of turns on each coil is equal to N. Current in both coils is equal to I. Distance between both the coils is equal to R. Let us consider P point Q at a distance D from the center. Then one coil is at a distance of R by 2 plus D from point Q. Magnetic field at point Q is given as B1 is equal to mu naught NIR square 2 bracket R by 2 plus D whole square plus R to the power 3 by 2. Also, the other coil is at a distance of R by 2 minus D from point Q. Magnetic field due to this coil is given as B2 mu naught NIR square upon 2 multiplied by R by 2 minus D whole square plus R square to the power 3 by 2. The total field the total magnetic field B is equal to B1 plus B2. So putting the value of B1 and B2, we get mu by mu naught I r square upon 2 bracket r by 2 minus d whole square plus r square to the power 3 by 2 plus r by 2 plus d whole square plus r square to the power 3 by 2. Upon solving, we get mu naught I r square upon 2 r 5r square by 4 plus d square minus rd to the power 3 by 2 plus 5r square by 4 plus d square plus rd to the power 3 by 2 now mu naught I r square upon 2 multiply by 5 r square upon 4 to the power 3 by 2 1 plus 4 by 5 d square upon r square minus 4 by 5 d upon r to the power 3 by 2 1 plus 5 4 by 5 d square upon r square plus 4 by 5 d upon r to the power 3 by 2. For d is less than r, neglecting the factor d square upon r square, we get mu naught I r square upon 2 is equal to 5 r square by 4 multiplied by 1 minus 4 by d 4d by 5r to the power 3 by 2 plus 1 by 4d upon 5r 3 by 2 is equal to mu naught I r square upon r square n upon 2 r square 2 r cube multiplied by 4 by 5 to the power 3 by 2 bracket 1 minus 6d upon 5r plus 1 plus 6d upon 5r. B is equal to 4 by 5 to the power 3 by 2 mu naught I r mu naught I n upon r. Putting the values 0.72 mu naught I n upon r. Hence, it's proof that the field on the axis around the midpoint between the coils is uniform. This is the end of today's class. Before we bind up, we have a small request. Please like, share, and subscribe our channel among your friends, relatives, and known ones. Please click on the subscribe button to support us and also click on the bell icon to get automatic updates whenever we load a new video. Thank you very much for watching our videos and supporting us.